All right, today we're going to look at chapter 3 titled Describing Relationships. Really, what we're going to be thinking about is there a relationship between two quantitative variables? If we know the value of one variable, can it help us predict what the value of the second variable will be? So, knowing one will help us predict the other. There's a relationship between any two quantitative variables in the world. Doesn't matter what the two variables are, there's a relationship. Just because there's a relationship and we can make predictions, it doesn't mean that there is a causal relationship or that one variable is causing the change in the other, even though there may be a very strong relationship that helps us make predictions. So first, we're going to start by defining these two variables we're looking at. If we're trying to see does one help us predict the change in the other, then we must have a explanatory response variable relationship. Explanatory variable is the variable that is explaining the change in the response variable. The explanatory variable must always live on the x-axis. So explanatory variable always lives on the x-axis. It's easy to remember, explanatory x. The response variable is always the y value. So response always lives on the y-axis. Anytime we meet a set of data, we want to see visually what does it look like. We want to graph it. In chapter 1, we looked at bar graphs and bar graphs and box plots and histograms and stem plots. Well, in regression, we're only going to be dealing with scatter plots. Very simple for a scatter plot. You plot each dot on the x and y axis and you're done. To make a scatter plot, you must draw your x and y axis, scale your axes, and then simply plot each dot where it lives. Now, looking at this, it appears to be somewhat of a relationship. This looks like a positive relationship. As x is getting larger, so does y. So we would say this is a positive association. We must label the axis, hand, span, and centimeters for the explanatory variable, and the response variable y would be the number of Starburst candies. So in this problem, we're trying to determine, does the size of your hand help predict how many candies you could grab out of a bowl? For instance, in class, your teacher is going to pass around a giant bowl of Starburst, and you're allowed to grab one handful as big as you want, and that's your candy for the class. So could we predict, based on the size of your hand, how many Starburst candies you'd be able to grab out of the bowl? And looking at this scatter plot up here in the top right, it looks like, yeah, there's a pretty good relationship between the two. As your hand gets bigger, you can grab more candy. No real surprise there. The larger your hand, the more stuff you could grab. So again, for a scatter plot, label the axes, scale the axes, and then plot the points. Most of the scatter plots we make, we will do using technology or our TI calculator. However, we may have a need every once in a great while to construct a scatter plot by hand. So we have explanatory, x, response, y. Make a scatter plot. We're going to start the same process for every one of these problems for regression. How do we describe what we see in the scatter plot? To describe a scatter plot, and we will need to talk about form, direction, strength, and is there anything unusual? When we first started analyzing data, we would always talk about the three things: shape, center, spread, shape, center, spread. Well, that's when we were looking at a single variable. When we're looking at a relationship between two quantitative variables, we're no longer going to talk about shape, center, spread. Instead, we're going to talk form, direction, strength, and the same is unusual. Is there any unusual features, any outliers, anything that doesn't match the overall pattern? As you can see below here, there are 6 different scatter plots. Form, does it look linear or not? Direction, positive or negative? Strength, strength is referring to how close are the dots to being perfectly on a straight line. Therefore, the 6th graph here would be much stronger than the first 5 because these dots all appear to be very much on a straight line. So strength is telling us how close are the dots to being on a straight line. The strongest we could possibly get would be every dot lying on the line. So form, direction, strength. Form's coming up later on. Right now, we're going to talk about direction, which is very easy to do. It's either a positive association, a negative association, or no association at all. A positive association means that as X gets larger, so does Y. So for example, graph 3 would be a positive association, and so would graph 5. Very clearly, as X gets larger, so does Y. We would say there's a positive association. Yeah, I kind of thinking about, could I find a line of best fit? We won't refer to it as that term, but that's what we need to think about it as. What line would fit this data the best? So for graph 3, probably a line running through something like that clearly has a positive slope. So association, you can think of it as the slope of the line that would best fit the scatter plot that we have made here. Graph 5 also has a positive association. Clearly, as X gets larger, so does Y. A negative association would be the opposite. As X is getting larger, Y is getting smaller. So this would have a negative slope in graph 4. Graph 2 would also have a negative slope. Or sometimes there's really no association or no real relationship at all. If you look at graph 1 here, it's hard to tell. Is there a positive slope? Is there a negative slope? Is there no slope? Is there an undefined slope? I don't know. So there we would say there's really no association between this explanatory variable X and this response variable Y.